Okay, so we've already talked about how solving quadratics is nothing new. We already have a couple methods for solving quadratics, one of them factoring, another quadratic formula. But today we're going to look at quadratics where we can solve them by taking a root. So step 1 is to isolate the x, get rid of anything extra. Step 2, take the root. Step 3, do anything necessary to solve for x at that point. So to get x by itself, what's got to go? A negative 4. So we use inverse operations. We will add 4 to both sides. Okay, so once we get x to a power, and that's all we have left, x to a power, then we're going to take the root. This power is the second. It's being squared. So what root will I take? The square root. All right, so we take the square root of this side, we take the square root of this side. Now, when you take a root in order to solve a problem, if that root is an even root, like a square root, when we take even roots, we get plus or minus. Because if I squared positive 8, I would get 64, but also if I squared negative 8, I would get 64. So when I take the square root of 64, I have two possibilities, positive or negative 8. Now over here, the square and the square root cancel, and we're left with x minus 3. So we actually have two situations. We have x minus 3 could equal 8, or x minus 3 could equal negative 8. Ah. So to solve these, I would add 3. Then I get x equals 11, or I add 3. I get negative 5. X equals 11 or negative 5. So either of these answers, when I plug back in, would give me a true statement. Any questions? Okay, let's look at example 2. Ooh, are you guys ready for your notebook quiz tomorrow?
What?
Notebook quiz tomorrow. Make sure you bring all your notes.
Notes?
Yes, notes. And your homework. Because every day we start class by correcting homework. So, notes and homework for Unit 2. Nothing from Unit 1.
I think I just cleaned it.
I got, yeah. I know.
Unit 2 starts.
Maybe something, some of it.
Good luck.
Oh, no.
Alright, example 2. Example 2. Alright, so we need to get x to a power by itself. So this time more stuff has to move. So what do we move first? The 5. So we get 2. X plus 1 squared equals 48. Now what do I do? Divide by 2, multiply by 1/2. Very good. So we get x plus 1 squared equals 24. So now I'm to the point where I take the root. It is a square, so I take a square root. When I do, I get plus or minus. Now 24 is not a perfect square, but it will simplify. What perfect square is a factor of 24? 4. Breaks up into 4 times 6. So this becomes plus or minus, the square root of 4 is 2, and the 6 stays under. And then we move the 1 over. Now, this answer is irrational, and it's actually 2 answers, but you're welcome to leave it like this. The 2 answers are -1 plus 2 roots of 6, and the second answer is -1 minus 2 roots of 6.
You said we can leave it like that.
Now, we have solved quadratics before. We know that a quadratic can have 0 real, 1 real, or 2 real. And when we looked at it before, we tied it into its graphs. If it has 2 real solutions and we thought about it as the function, that means it crosses the x-axis twice. Okay? So this would be where we would visualize our two real solutions. You don't have to write this part down. If it can also have one real if the vertex is sitting on the x-axis. This is how we would have one real. Okay, but we can also have no real solutions, right? If we had no real, it would look like this and never cross the x-axis. So if we visualize this as the function, this would have no real solutions. But this year we learned that there's more than just real. There are imaginary. So we might end up with ones like number 3. That even though we solve it, and we get to the point we know there are no real solutions, we can find those imaginary solutions. Okay? So for this one, what do we do first to solve it? Divide by 3. And so when we divide by 3, we get x minus 5 equals squared equals -9. Now, in Algebra 1, when you learned to do this, you wrote no real solutions because you didn't know about complex numbers or imaginary numbers yet. But now we do. So we know when we take the square root of both sides, it is possible to simplify this. The square root of -9 is plus or minus 3i. And then we move the 5 over. So these aren't real, but they are solutions. They're imaginary. Okay, any questions about solving quadratics by taking a root? All right, well, let's go solve some cubics next. Not much different. Actually, let's think about a cubic. All the cubics we've studied, which are the same kind that we're going to be, how many times do they cross the x-axis? Once. Every one of them. So, the type of cubics we are studying can only have one solution. Now, we can have other types of cubics, and a cubic can actually have up to how many solutions? 3, because it's a third power. But the kind we're studying right now all look like this. So, x minus 3 cubed. If we were to solve this, we already have the x isolated, so we're good. A square root won't help us because we don't have a square. We need to take the cubed root. Very good. Cubed root. Cubed root. All right, so when we take the cubed root of both sides, the cubed root of 8 is 2. Because 2 times 2 times 2 is 8. Now, earlier this year, you were responsible for perfect cubes 1 through 6. Let me remind you of those. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And 6 cubed is probably the one you're going to forget, but it's 216. Okay? So next Friday's test will be no calculator. So obviously I would only give you perfect cubes that would fall into these categories. Alright, so to continue solving this, we would just add 3 to both sides. And we get x equals 5. Something. Don't write this down. What if we had this? Instead of 8, it equals 16. Let's just talk through this. We'd still take the cubed root. But just like we can simplify square roots, we can simplify cubed roots. What is a perfect cube that divides into 16? 8. 8 goes in there 2 times. So we could actually solve this problem. This would simplify to, what is the cube root of 8? 2. So this is 2 times the cubed root of 2. This right here. And then we can move this back over. Now, why did I put plus or minus? Because it's a cubed root. Even roots give us the positive and the negative. Because when I take the square root of 4, I get plus or minus 2. What does that mean? That means 2 times 2 is 4, and negative 2 times negative 2 is 4. But cubed roots only have one answer. The cubed root of 8 is positive 2, because 2 times 2 times 2 is 8. I can't do it any other way. It only has that one unique answer. Okay? Let's look at our next example. All right, this one, it's got lots of extra stuff. This is, I know y'all get excited every time you notice I'm on the last slide. This is slide 9 of 9. You've never noticed that? Oh. Well, now you can look for it. You'll know how close we are to being done. Yeah. Last example right here. Okay, so we're trying to solve for x. What goes first? The plus one. Okay, now I have a fraction. Anytime you have a fraction, you multiply by the reciprocal. What is the reciprocal of 1/4? 4. So I would multiply both sides by 4. But anytime we have a fraction, we would just multiply by the reciprocal. So this gives me x minus 2 cubed equals negative 64. Okay? So I have an isolated power. I take the root. Take the root. Now, is it possible to take a cubed root of a negative? Yes. What is the cubed root of negative 64? Negative 4. Because negative 4 times negative 4 times negative 4 is negative 64. So with cubed roots, if you're taking the cubed root of a positive, your answer is positive. But if you're taking the cubed root of a negative, your answer is negative. We don't get imaginaries. You only get imaginaries with those evens. Even roots, square roots. Okay, so this leaves me x minus 2. And so I add 2. And I am done. Okay, so what I want you guys to do as you tackle your homework, and I want you to do this every night, look at the problems. Don't just get in a rut going, every time I take a square root. No, because sometimes I'm going to give you squares, sometimes I'm going to give you cubes, I might throw in some absolute value. Okay, so I want you to always be thinking, look at the problem and think, and then start. Okay? At this point, we have 20 minutes of class time. I should be able to check your homework before class is over. It's 10 problems. You have time to finish. Okay? So, you're welcome.
You have a